Hey everyone, in this video we're going to look mostly at parallel box plots, but I thought we'd also have a brief introduction of bivariate data and how we can display that. But I think in terms of level of difficulty, parallel box plots is probably the hardest part here, except for scatter plots and regression analysis, which we're going to look at completely separately. But parallel box plots is going to be the focus of this video. So if you need to learn about anything else, you can watch the Ed Rollo videos. I am going to go through a bit of theory, but the questions will mostly focus on parallel box plots. All right, so we're now looking at bivariate data. So before we were looking at univariate data. So the main difference is one variable, the other one is two variables. So think of unicycles and bicycles. So a unicycle has one wheel, so univariate has one variable. Bicycle has two wheels, bivariate data has two variables. Okay, so just thinking of the prefix of both those words. All right, so when we're looking at bivariate data, we tend to have an explanatory and a response variable. So if you do psychology, the explanatory variable is sometimes referred to as the independent variable, and your response is your dependent variable. So the independent one is one that you can't really control, and it influences the dependent variable. So if you're a bit unsure about which one is which, just think about, well, which one influences the other. So if we think about the electricity usage, that might depend on the weather. Okay, so using more electricity, maybe when it's hot because we put the air conditioning on, or when it's cold. So the weather is something we can't control, but we can control what's happening with our air conditioning unit or our heating. So therefore it influences our electricity use. With this example that we can see on the screen, so just looking at this table, it has told us that the explanatory variable is gender, and then we've got our response variable, which is exercise habits. So if you're unsure, you can just say, all right, does the exercise influence our gender? So if I was to exercise more, would my gender change? Probably not. And then you can think, well, being male or female is something that you can't change, and it might influence your exercise habits. So I don't really want to go into the politics of who exercises more or whatever like that, but just think about, well, I can't really change the gender if I exercise more or do no exercise. So that can help you think about, well, which one is responding to the other. All right, so explanatory is your independent, it is changing your response variable. So think about it also in terms of study. So if you study more, you're probably going to get a greater result. It's not the other way around. You don't get your test result back and then all of a sudden the number of hours you studied changes. So always think about, well, which one is influencing the other. Sometimes words are used, so we can see in this exam hack, we can see explain changes or predicts, and that can help us decide on which one is which. All right, so to display bivariate data, we can have a two-way frequency table. So it's probably a good idea to have an example of this. So we've got the gender and exercise habits. You can have it around the other way. It doesn't have to have the explanatory up the top and the response on the side, but you can just see that this cell here has both male and exercise. So it's the number of males who exercise. You do need to be able to interpret a table. The number of females who don't exercise, 946. Now, you can also convert that into a percentage. So I'll just go down here. All right, so converting it to a percentage just helps us make a comparison. So if we have a look at the two-way table without the percentages, we can see the number of males and the number of females is different. So it would be okay to compare them if they were the same, but because they're different, when we make a comparison, we do need to have the percentage frequency table. So need percentages to compare. Now, when we're making a comparison, basically if there was a difference, which we can see there is a difference here, then we can say, well, exercise habit can be related to gender, right? Because there is a difference. If they were the same, then we can kind of conclude that there is no difference between the two. So exercise habit is not caused by gender. All right, here we've just got how to calculate a percentage. So please make sure you've got an example of that in your bound book, especially if you have trouble with doing percentages. So we just take the data value over the column value. So we can see for males, it's 3,028 over the total, which was 4,560, and then multiplying it by 100 to turn it into a percentage. I'm just going to read through what it says here, not everything, just this last part. So from this percentage two-way frequency table, we can see there is a difference. So that's what I was saying before. There is a difference in exercise habits between males and females. Whenever you're commenting on statistics, you need to actually report what they are. So here we can see we've got 66.4% of males exercise, whereas only 53.4% of females exercise. So making that comparison, you do have to, the phrase whereas is a comparison, or you can say one is higher than the other. This suggests that there is an association between gender and exercise habits. So remember, when there is a difference, we could say that an association could be present. It suggests that there could be an association. If the male and female percentages had been approximately equal, which is what I said before, we would have said there is no association, which would mean knowing a person's gender doesn't tell us anything about their exercise habits. So that's a good summary of a percentage frequency table. All right, then we've got segmented bar charts. So I did cover segmented bar charts in a separate video, but we only had one bar as opposed to comparing. So here we've got the same data as in this table, but now in a segmented bar chart. So we've got one column for male and one column for female, and then their percentage frequency. And we've got a color for each. So if we were just looking at one group, you can probably say, all right, we'll get rid of that. We're just looking at the male group. But if we're comparing males and females, because gender is one of our variables, you can have a bar for each. And you could have several bars, all right? You just don't have two. It depends how many groups there are in your variable. So gender, we could have male, we could have female, we could have no gender. We do know there's, some people identify as all different genders. You could have all them as well, but for this question, we've just got male and female. All right, so as I kind of alluded to before, so parallel percentage segmented bar charts, whoa, that's a bit of a mouthful, are particularly useful when we are dealing with data from several populations. So you might be comparing different states or different countries. Maybe it is one school compared to another, or one class compared to another. All right, but then you've got the variables separated as well. So remember, exercise habits, it was either no exercise or exercise. So that's what we could have there. All right, back to bag stem plots. So we can use them when we're comparing to numerical, a group with numerical data. So here we're comparing class A and class B. So we've done stem plots before, but this is now just comparing two groups as opposed to just looking at one group. I'm just seeing what is written here. As with one-sided stem plots, when there are a small number of stems for back-to-back stem plots, we split the stem to see the distribution more clearly. So what this just means is if you had a lot of data values, maybe in the teens, you could do 1, 1, 2, 2, 3, 3. So that just means that if I had a value less than 15, it would go there. And then if I had greater than 15, it would go there. Just so you don't have a very long leaf, if that makes sense. All right, always have a key. Here we've got a key for both, but you probably only need one key. And actually, that's interesting that they've done that around the other way. What else was I going to say? When you're comparing them, we'll do this in a separate video, but when you're comparing two groups, you do look at the, actually we might do it when we're looking at parallel box plots. You do look at the shape, you do look at the center and the spread. So remember, your shape is whether it's symmetrical or skewed and what type of skewed it is. Center is your median, and the spread, we can do the interquartile range. So for back-to-back stem and leaf plots, you can just compare class A to class B. Just seeing if there's anything else I want to think about there. Okay. All right, so in this video, we're going to focus on questions relating to parallel box plots. So box plots are mostly used because it's more visual. We can see the median for each group. So here's the median for each class. So what are we looking at? We're just looking at 4 classes, test results for 4 classes. So we can see class D has a higher median and class B has the highest value. Class A has the lowest value. And we can also look at the interquartile range. So it tells us how varied the data is. So class B looks like it's got the smallest interquartile range, but they're all relatively the same. And then we could also talk about their shape. So as I said before, up here, we can talk about their shape, center, and spread. So that's just your positively skewed, negatively skewed, or symmetrical. So the first one, it is negatively skewed. Class C is positively skewed. Now class B is an interesting one because we've got the median here, but we've got this long tail. So focus more on that median. So that's going to tell us it's positively skewed. And then for the last one, it is, well, the median is kind of in the middle, so it is symmetrical. Now, if you're unsure, I'm pretty sure we've got box plots with our histograms. If I just go back up to our notes, when we did box plots, I've already passed histograms. Here they are. So it's really hard to spot them. I've circled them, right? So there's your box plots as well. So if you need to refer to your notes as to whether they're symmetrical or positively skewed or negatively skewed, you can refer to these notes here. All right, now also with our box plots, you can do a 5-number summary as well. Just trying to think. Yeah, we can have a look at a 5-number summary if we need to do it in the questions. We've already done 5-number summary for box plots. Alrighty, let's go on to some questions. So these questions are now taken from chapter 2, so we're in 2C. Might just get some space for these questions. Alright, so the parallel box plots show the distribution of pulse rates of 21 females and 22 males. So we've got the blue box plot representing females and the yellow one representing males. So with when you've got parallel box plots, you do put them on the same axes, so you can easily compare them. You don't do separate ones, just because when they're on the same one, we can easily see where our median is. So we can see for females, it's really hard to see. Let's get another color. No, let's do pink. So that's the median there, which is higher than males. I can see that the female has a greater spread. So there's your interquartile range, which is clearly bigger than male. And then in terms of shape, well, female looks approximately symmetrical, and so does male. So female just varies a little bit more and also has a higher median. All right, so looking at question A, identify each of the variables and classify as categorical or numerical. All right, so we've got here pulse rates. And then, now I would call this sex, not gender. So, but you can call it gender if you like. Pulse rates, and it's measured in beats per minute. And that's important to know because remember with continuous numerical data is being measured. So it just says we have to classify it as categorical or numerical. So pulse rates is numerical, but it is also continuous. And then sex would be categorical. All right, use the box plots to compare these distributions and draw an appropriate conclusion about the association between gender and pulse rate. All right, so they've used gender, so you can use gender if you like. Okay, let's go to B. So remember for each one you're comparing, but I'm just going to write it down before we compare using sentences. So remember when we're comparing, we do shape, just go down, center, and spread. All right, so the shape is whether it's symmetrical or skewed. So let's just get rid of all this because it's a bit easier to see. All right, so female, it looks approximately symmetric, and I would say for male it is approximately symmetric. I mean, the median is just a little bit to the side, but I would say it was approximately symmetrical. All right, so we'll do that for both. All right, the center, so we're looking at the median here. So for female, it's here, we've got to go all the way down. Now, we don't have this number on our scale. It's not 0, that was a circle. So we just got to work it out. So what are we going up by each time? We're going from 70 to 80. So I think we're going up by 2. So 72, 74, 76, 78. All right, good. So that is going to be 76. And then we do the same thing for the males. So that one is halfway between here, so 73. And then the spread is our interquartile range. So I'm just going to go, sorry, I need to rub that out. All right, so interquartile range is going from here to here. So the first one is at 68, and then we're at 82. So your interquartile range is 82 minus 68, which is 14. And then for the males, we're going from 68 again, but this time to 76. So that is going to be 8. All right, I'm just going to fold my laptop over while I do a bit more writing because it's a bit hard to write on the screen. So we're going to draw an appropriate conclusion. So when we're comparing, all right, we can make comparisons. So both the female and male distributions are approximately symmetrical. And there's no outliers. I probably should have written that before, with no outliers. Females have a greater median. Remember, we have to state what that is. Then males. All right, remember we've got to make that comparison. So I did make that comparison by using the word greater. And females have a higher interquartile range than males. So let's just go on. Oh, running out of room. So we can say that, you know, if you were doing the interquartile range, this just means it's more varied. All right, and then the median has a higher or greater center, or higher center. All right, so your center is your median. Now, if we're making a conclusion, because there is a difference in our medians, and there's also a difference in our interquartile range, but we'll just focus on the median. There is a difference in median values, therefore we can, oh, let's not say we, it is suggested that there is an association between pulse rates and sex, or you can say gender if you want to, gender. All right, let's move along. So before we do, if the box plots were pretty much the same, so if the centers were around the same, so they don't have to be both exactly 76, but maybe if one was, say, 75 and the other one was 76, and then the interquartile range was pretty similar as well, then you could conclude that there was no association between the two variables. All right, question 6. The parallel box plots show the distribution of the lifetime in hours of 3 differently priced batteries. The two variables displayed here are battery lifetime and battery price, which is numerical and which one is categorical. So it is easy to see that battery price, even though we think of price in terms of dollars, here it's measured as low, medium, or high. So that's categorical. Categorical ordinal. So categorical is battery price. So we use parallel box plots when we have one categorical variable and one numerical variable, which you would have seen in the previous one, and this one here. So lifetime is measured in hours, so that is numerical and also continuous. Now, battery price is categorical, but it's also ordinal. But you can use ordinal or you could have nominal. Doesn't really matter as long as it's one is categorical and one is numerical. Do the parallel box plots support the contention that battery lifetime depends on price? Write a brief explanation. So you can't just say yes or you can't just say no. For this one it is yes. And you got to say why. So there is a difference in medians. That's all you have to do. You don't need to go and write a big summary like I did here, because that was a different, so we were making a comparison between the distributions. So we needed to comment on shape, center, and spread. When you're just seeing if it supports a contention, then you can just refer to the medians. Yes, the median what do we call it? Battery lifetime for high-priced batteries is higher. And then we can just say what that is. So looking at this value going down, it's 51. Then medium priced which was at 2, 4, 5, 35 hours. And low priced. I should probably write median equals low price median equals, and then the last one is at 32. All right, so there is a difference. Yeah, so the median battery lifetime for high price batteries is higher. Medium equals 51. Then medium priced, which has a median of 35 hours, and low price median of 32 hours. Therefore, the parallel box plots, probably don't need this last part, but we'll put it in anyway. Box plots support the contention. All right, the contention's written in the sentence, so in the question, so we don't need to state it again. All right, now I think we've got one question to come. Oh, we've glitched. Come on, there we go. All right, so we've got back-to-back stem and leaf plots here. And I thought it would be good to do this one because I don't think in the previous video we kind of covered the shape of a stem plot. And I also wanted to show you how to do parallel box plots on your calculator. So I'm going to use this data to do parallel box plots on the calculator. So we've got the following back-to-back stem plots displays the distribution of the number of hours per week spent online by two groups. By a group of students and their year level. So we've got year 10s and year 11s and the number of, the amount of time they've spent online. Classify each of the variables as categorical or numerical. So we've got, and variables are italicized, so number of hours is going to be your numerical. And then year level is categorical. Categorical. All right, use the stem plots to compare these distributions in terms of center and spread. All right, doesn't ask for the shape, but we'll do that anyway. Draw an appropriate conclusion about the association between the year level and the number of hours students spend each week. All right, so let's do the shape first. So when we're looking at the shape, I always turn my stem and leaf plot to the side. So it's a bit hard to turn my computer around because you're not going to see it, but kind of think about you're looking at this as a histogram maybe. So we can see here we've got a peak and we've kind of got this tail going off to the side here. So that would be, let's just do year 10, year 11, and then we're going to do shape, center, spread. All right, so for year 11, it is negatively skewed. All right, then for year 10, I do the same thing. Oh, it's a little bit harder to see because our values go the other way. All right, so notice how, yeah, it's a bit harder when you've got this, but if we were to reflect that, it is going to have the same shape as the other side, so it is also negatively skewed. When we put it into the calculator, you'll be able to see it as box plots. All right, your center, I'm just going to get rid of that so I'm not drawing all over it. So do we know how many there are? No. So let's count how many we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So halfway is going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, always just check that there's 8 above. 1, 2, 3, 4, 5, 6, 7, 8. So our median for year 11 is 16.5. So halfway between 16 and 7. All right, and then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So our median is going to be our 9th value 1, 2, 3, 4, 5, 6, 7, 8, 9. And then just compare 1, 2, 3, 4, 5, 6. Oh, did I miscount before? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right. 1, 2, 3, 4, 5, 6, 7, 8. 9. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I think I just made a mistake when I was counting before. So that center is at 20, so we can see that they're different. When we're referring to spread, we're doing the interquartile range. So going back to when we did the interquartile range, I've split my box plot into halves. So there's my lower half. There are 8 numbers there. So my lower quartile is going to be, let me just get that, halfway between the 4th and the 5th. So here, so it's going to be 13. Let's make sure I do that in the right spot. So Q1 equals 13. And then for my upper half, 1, 2, 3, 4, all right, halfway between 22 and 23, so it's 22.5. So your interquartile range, remember, is Q3 minus Q1, so that's going to be 9.5. All right, so let's do the same for the other side. So 1, 2, 3, 4. Oh, hold on. 1, 2, 3, 4. So we're halfway between 13 and 15, which is 14. Oops, let's do it over here. Q1 equals 14. And then we'll do the upper half. 1, 2, 3, 4. So halfway between 23 and 24. So 23.5. So that's also going to be 9.5. All right, so if we were making a conclusion about the association, they're both negatively skewed. Not that we're going to refer to that anyway. They've got the same spread, but their center is different. So we can say there is an association because there is a difference in their center. All right, let's just have a look at now doing this on the calculator. So if you had trouble getting your median and your interquartile range and your upper and lower quartiles, I'll show you how to put all this data into your calculator. All right, I've just also looked at the answer and they had 13 here in the textbook, and I've just checked as well, and I don't know, I kind of feel like I'm right, but let's double check. All right, putting these values into our calculator. So we go menu, statistics, anything written here we can just clear. So clear. All right, so I'm going to do year 10 in list 1. So when we're reading the left side, remember we do a 0 first and then the next number. So this first one is going to be 0, 0, just a 0, and then we've got 8. All right, so don't forget that 0 is also a number. So there is one person who spent 0 hours online. All right, and then we go into the next column. So we've got 11, and then we've got another 11 and 13. Then we go to the next one, 15, 16, 17, 18. And then we can go down to the next one, 20, another 20, 21, 21, 23, 24, 24, and then the last one, 25, 28. This is also an example of having it split. So because we've got values only going from 0 to 28, it's probably better, so with that we don't have very long leaves on our stem and leaf plot, that we split our stems. So you can see that we've split the stems going from 10 to 14, and then this one would be 15 to 19. All right, moving on now to year 11. So we've got 5, 6, 7, 12, 14, 15, 15, 16, 17, 20, 21, 22, 23, 23, 24, 27. Now, did I do another value there? What did I do wrong? Now, I remember counting 16, but did I count 17 before? All right, I just need to check what I've done. I did 11 twice. All right, so we'll just go edit, delete, cell. All right, there we go. I did the number 11 twice. It's only there once. All right, so when I'm calculating, if I wanted to do, oh yeah, we can do that. No, what am I doing? Calc, to variable. Okay, we can just do the variables separately. So we'll just go 1. All right, so looking at the year 10. So I had a median of 20, which is correct. There it is. My lower quartile was 14, yes. Upper quartile 20.5. So that means I calculated my interquartile range correctly. All right, let's have a look at doing the same thing for list 2. All right, so the median 16.5, lower quartile 13, upper quartile 22.5, and I'll just make sure I did, yep, it's definitely 9.5. I think the textbook just had the wrong answer. All right, when we're drawing our parallel box plots, all right, so this is important because we do it the same as we did before. So we go med box, we want to show outliers, just make sure you've got it turned on, and we're doing list 1. And then up here we can go and draw another box plot. So we're going to med box, we want to show outliers, but this time we're doing it for list 2 because we're doing it for year 11. Just make sure you check here for on because we want to see it. If it was off, we're not going to see it. And then we click this and you can see your 2 box plots. And now they both looked negatively, remember I said they were negatively skewed? We've got a long tail for both of them. The median for this second one is a little bit more to the center. What was that one? The year, which one was which? So the blue one is year 10 and then the red one's year 11. Okay. All right, looks a bit more, maybe because we've got this peak up here. All right, so we've got those long tails which make it look like it's negatively skewed, but this center being a little bit to the side kind of, throws it off a little bit. Not as clearly obvious as the previous one. All right, so if you have trouble with doing all of this by looking at your stem and leaf plot, you can put the values into your calculator. Just make sure when you do it, you read your key. So we can see it's got 21 hours, 16 hours. So when we're reading it, we don't have to put a decimal point in. Sometimes it could be 1/6 and that's read as 1.6 hours. You just got to take care of how to interpret your values. All right, I think that is the last question. All right, and then we're looking at scatter plots, which is pretty straightforward. All right, so we're looking at scatter plots, but not going into too much detail. All right, bye guys.